Today's presentation is Cognitive Theory and E-Learning with a focus on emerging technologies. I'll be the presenter today. I'm Ashley Driver. Thank you for joining me today. On the agenda today, we will discuss abstract, introduction, theoretical framework, emerging technologies in e-learning, cognitive load and technology enhanced learning, case studies and applications, empirical evidence, challenges and limitations, future directions, in the conclusion of our presentation. Emerging technologies have revolutionized the educational landscape, presenting novel opportunities and challenges for e-learning. Cognitive theory, which encompasses a range of psychological principles that describes how people learn and process information, serves as a cornerstone for designing effective e-learning environments. This presentation dives into the integration of cognitive theory with e-learning, emphasizing the transformative role of technologies such as virtual reality, augmented reality, and artificial intelligence. A comprehensive review of research articles from the past 5 years forms the basis of this explanation, highlighting the impact of these technologies on cognitive load management and learner engagement. The literature synthesis reveals that while emerging technologies can enhance learning processes, they also necessitate careful consideration of cognitive principles and enhancement through technological innovations. During this presentation, we will contribute to the field by providing empirical evidence, discussing challenges and ethical considerations, and suggesting future directions for research. The implications of this study extend to educators, instructional designers, and technologists, aiming to foster environments that support cognitive development and deep learning in practical real-world settings. Some of the key words that we'll discuss today through the presentation are cognitive theory, e-learning, emerging technologies, virtual reality or VR, augmented reality, AR, artificial intelligence, AI, cognitive load, and instructional design. Cognitive theory is a learning theory that emphasizes the importance of internal mental processes and understanding how people learn through active learning, information processing, and instructional design. E-learning is electronic learning, is a form of education where learning is conducted through electronic media. Emerging technology types: augmented reality, AR, enhanced perception of reality by overlaying digital information on the physical world. Artificial intelligence, machine or software intelligence that can perform tasks typically requiring human cognitive. Virtual reality, VR, computer-generated simulation of a 3D image or environment that a person can interact with in a seemingly real or physical way using special electronic equipment. Cognitive load, the amount of mental activity imposed on working memory at any given moment. Instructional design, the process of analyzing learning needs and goals and then designing, developing, implementing, and evaluating instructional materials and experiences to meet those needs. Now let's do an introduction into the following topics. The digital revolution has ushered in a new era of educational requirements where e-learning has emerged as a pivotal component of modern education. The intersection of cognitive theory and e-learning, a relatively novel research topic, has garnered significant attention as it offers a lens through which the learning process can be understood and optimized. Cognitive theory, with its roots in understanding the intricacies of human learning and information processing, provides a robust framework for designing e-learning environments that are both effective and engaging. This paper seeks to explore the application of cognitive theory with e-learning, particularly emphasizing the transformative role of emerging technologies. Emerging technologies such as VR, AR, and AI have the potential to redefine the e-learning landscape. These technologies promise to create immersive and adaptive learning experiences that cater to individual learning needs, enhancing their learning process. For instance, VR can simulate real-world scenarios, providing learners with hands-on experience in a controlled and safe environment. AR can overlay digital information onto the physical world, enriching the context and depth of learning materials. AI can personalize learning pathways by analyzing learner data and adapting content in real time. However, the integration of these technologies into e-learning must be cautiously approached. Cognitive theory highlights the importance of managing cognitive load and to prevent learner overload and ensure effective knowledge acquisition. As such, the design and implementation of technology-enhanced learning environments must be informed by cognitive principles to support the learning process rather than hinder it. This paper reviews recent articles to examine the impact of emerging technologies on cognitive load management and learner engagement in e-learning. Through this presentation, we will aim to provide empirical evidence of the benefits and limitations of these technologies, discuss the challenges faced by educators and instructional designers, and suggest directions for future research. We will also discuss ongoing discourse and efficiency of technical enhanced learning by bridging the gap between theoretical frameworks and practical applications. It offers insights that can inform the development of e-learning environments that are cognitively engaging and technologically advanced. Let's look at the theoretical framework. The theoretical framework of e-learning is anchored in cognitive theory, which has evolved significantly over the past few years. As Meyer explains, cognitive theory and multimedia learning presents that meaningful learning involves the active processing of information through dual channels for verbal and visual material within the constraints of limited working memory capacity. This theory has been instrumental in guiding instructional designers, particularly in multimedia environments where learners engage with words and graphics. Recent studies have built upon these principles, examining the paradoxical findings where increased cognitive load does not necessarily impede and may even enhance learning performance. This has led to a deeper understanding of how cognitive load can be managed effectively in digital learning environments. The cognitive process framework for learning with digital tools integrates core ideas from instructional and cognitive psychology to explain learning mechanisms with digital tools, emphasizing the utilization of learning opportunities and knowledge learning instructional framework. Furthermore, studies have categorized strategies to optimize cognitive load into methods that reduce intrinsic cognitive load, enhance cognitive load, and accommodate individual differences in learners' expertise levels. These strategies are critical for developing e-learning materials that are both technologically advanced and cognitively supportive. As e-learning continues to evolve with the integration of emerging technologies, the principles of cognitive theory remain central to the design and implementation of compelling educational experiences. The ongoing research in this field is essential for educators and instructional designers to create learning environments that facilitate cognitive development, deep learning. Let's look at some of those emerging technologies in e-learning. The past 5 years, we have witnessed a surge in integrating emerging technologies within e-learning, reshaping the educational experience and offering new avenues for cognitive engagement. VR, AR, and AI are the forefront of these transformation, providing immersive and personalized learning experiences that were once the realm of science fiction. Let's look at the first one, VR. Each one of these technologies shows a clip of a VR, AR, and AI. Those links are in the reference at the end of the presentation. You may copy and paste them into your browser windows and go take a look at them. They're very interesting how these technologies are being used in the classroom. VR in particular has been used for its ability to create fully immersive environments, allowing learners to engage with content hands-on. This technology has shown promise in medical education where students can practice procedures in a risk-free setting. The reference for that is Ballinson 2019. If you go and look at the article, they discuss how medical students are now using VR to work on patients in surgery instead of how we used to do it when back in the 1800s and 1900s, people would learn on the operating table, or they'd have to learn on a animal close to the human anatomy, such as a sheep or a pig. And now they're able to practice surgeries in the VR environment, which is safe for everyone. And they insert real world scenarios. So if they make a mistake, it shows up in the VR training. It's very interesting. The next technology we will discuss is augmented reality, AR, which adds another layer to this by overlaying digital information onto actual words, enhancing the learning material without disconnecting the learner from its environment. So this is a little bit different. This brings the learning into the real world. Something we use every day that you'll see that's AR is Amazon has AR technology in their app. So if you say you want to buy a couch or a rug, you can actually open up your camera and the rug will appear in your room on camera. So you can see how the rug or the couch or piece of furniture, whatever, fits into your environment. Same thing happens. Again, this video is at the end of the presentation, the references. Copy the link, go watch it. It's about 3 minutes. It's very interesting. Again, this is showing medical students how they use 3D bodies to look at different parts of different systems in the human anatomy. Very interesting. The last technology we'll talk about is AI. AI impact on e-learning is multifaceted, ranging from personalized learning paths that adapt to individual learners' needs to intelligent tutoring systems that provide immediate targeted feedback. This AI-driven systems not only cater to the cognitive aspects of learning, but also address motivational and emotional factors, which are critical for sustained engagement. The link here, again, goes to a YouTube video. It's about 3 minutes. The instructor here actually had AI, allowed us to use AI in building a robot in their STEM program. The only requirements were they had to use AI either in the robot or during the design of the robot, but they had to use AI in some aspect of their project and show the instructor how they used it. It was very interesting how each of the students took different approaches to it. Please go take a look at the video after this presentation. A growing body of research supports the integration of these technologies into e-learning platforms and demonstrates their effectiveness in improving cognitive engagement and learning outcomes. However, the rapid pace of technology advancement also presents challenges, especially in terms of ensuring equitable access and addressing the digital divide. As we look into the future, it is clear that learning technologies will continue to play a pivotal role in the evolution of e-learning. The ongoing research and development in this field will be critical in harnessing these technologies to create learning environments accessible to all learners. Cognitive load and technology enhanced theory. Cognitive load theory, CLT, remains a cornerstone of instructional design. particularly technology-enhanced learning environments. The theory that effective learning to occur, instructional designs may consider the capacity of the working memory and aim to minimize unnecessary cognitive load. Recent research has expanded on this, exploring the interplay between cognitive load, learners' resources, and self-regulation in digital learning environments. The advent of immersive technologies like VR and AR has introduced new dimensions to managing cognitive load. While these technologies can create engaging, realistic learning experiences, they also have the potential to increase extra cognitive load, which can deter from learning. To address this, researchers have proposed strategies that include constructive alignment, where learning activities are designed to align with learning outcomes, thereby balancing cognitive load. Integrating AI and e-learning platforms has led to the development of adaptive learning systems. These systems can dynamically adjust the complexity of learning materials based on the learner's performance, thus optimizing the intricate cognitive load. This personalization ensures that learners are not overwhelmed by the material and can focus on processing information relative to their learning goals. The research underscores the importance of designing e-learning experiences that consider cognitive load at every stage, from the initial presentation of information to the assessment of learning outcomes. By leveraging the principles of CLT and capabilities of emerging technologies, educators can create more effective, efficient learning environments that lead to the needs of diverse learners. So the very interesting thing about a lot of these articles, especially the AI adaptive learning system, each learner can start at the same beginning, but if someone is struggling in one area, they'll give answers that are easier. If the learner is learning the material faster, they'll start giving harder questions and material for them to digest. Adjacent to my career field in the military, the tests are already starting to do that. We have AI adaptive testing to where if you're taking a test and you keep getting the answers wrong, or if you keep getting the answers wrong, they'll keep giving you easy answers. If you keep getting the answers right, they'll give you the same or harder questions. So these research articles are very interesting, and I implore you to dig deeper and read these. They're very interesting. Some case studies and applications. The particular application of cognitive theory in e-learning is best illustrated through case studies that showcase real-world examples of how emerging technologies can enhance learning outcomes. Now let's look at some of those recent studies. Recent research has provided valuable insight into the effectiveness of e-learning models, particularly in the context of the COVID-19 pandemic, which has necessitated a rapid shift to online learning. One such study conducted at a university explored students' learning experiences in online education, highlighting the importance of technology competencies and the need for education and institutional support. This case study emphasized the responsive nature of online education to the emergent needs of learners, while also identifying areas of improvement. Another case study focused on e-assessment challenges during e-learning in higher education, applying the theory of planned behavior to understand participants' attitudes towards implementing e-assessments during online learning. The study's findings underscore the potential of e-assessment to enhance the learning experience if it appropriately supported the technology and education. These case studies and others in the field provide a rich source of data for understanding the complexities of e-learning, the role of cognitive theory and instructional design. They offer practical examples of leveraging emerging technologies to create engaging and effective learning environments that cater to the diverse learner needs. As e-learning evolves, these case studies will serve as valuable resources for educators and instructional designers seeking to implement technology and enhanced learning solutions. They provide empirical evidence of benefits and challenges of e-learning, informing future research and practice in the field. Next, we'll look at empirical evidence. Empirical evidence is the cornerstone of validating the effectiveness of e-learning strategies informed by cognitive theory. A review of recent studies reveal a growing body of empirical evidence that supports the integration of cognitive principles in e-learning environments. These studies have utilized quantitative methods to measure the impact of e-learning on students' academic achievement, with a notable increase in research intensity over the past years. One such study examined the effects of e-learning on university students' academic performance, finding that e-learning can lead to improved academic achievement outcomes when designed with cognitive load considerations in mind. Another systematic literature review highlighted the capabilities of e-learning systems to enhance organizational learning, emphasizing the importance of developing and adapting e-learning systems that align with organizational goals. Adapting e-learning systems before and during the COVID-19 pandemic has also been a focus of empirical research. Studies have identified factors influence the acceptance of e-learning systems, underscoring the role of technology in facilitating continued education during a time of crisis. Additionally, the research on online instruction in higher education has identified promising practices based on empirical evidence, including course design factors, student support, facility education, student engagement, and student success factors. These empirical studies provide a solid foundation for understanding the particular implications of cognitive theory in e-learning. They offer insights on how emerging technologies can be leveraged to create effective learning environments supported by evidence. Let's look at some challenges and limitations with e-learning. The implementation of e-learning, while transformative, is not without its challenges and limitations. Recent studies have identified several critical issues that educational institutes must navigate to successfully adapt e-learning systems. One of the primary challenges is the digital divide, which refers to the gap between those with access to modern information and communication technology and those without. This divide can significantly impact students' ability to engage with e-learning materials and participate in online education. This study was very interesting, the digital divide, because it did discuss how a lot of the impacts to students' ability to engage in e-learning materials and participate in online education was really affected during COVID-19. Inner city schools are rural schools that had less access to internet access or laptops or computers for their students, really saw a decline in the education of their students because participation was not available to those students. So again, another very interesting read. Another significant challenge is the readiness of institutions to adopt e-learning. This includes the availability of technical support, the quality of online course content, and the information technology skills of facility members. Without adequate preparation and support, the transition to e-learning can be fraught with difficulties, leading to suboptimal learning experiences for students. Again, the readiness of institutes, another good article to read, or a research study to read, due to the fact that we learned so much from the rapid shift to online learning, that education systems didn't have a e-learning instructional design or course content set up. So a lot of educators were trying to make do with come pick up papers or print out papers at home or go to a library for your students to learn because just they did not have access to those things. Again, another great read. Again, the rapid shift to online learning necessitated by the COVID-19 pandemic, it did highlight the need for e-learning systems to be functional, user-friendly, and engaging. Educators and learners are influenced by various factors, including self-efficiency, financial consideration, and educational effectiveness and technological infrastructure. Despite the challenges, the potential benefits of e-learning are significant. It offers flexibility, accessibility, and the opportunity for personalized learning experience. However, for e-learning to be truly effective, these challenges must be addressed through strategic planning, investment in infrastructure, and ongoing support for educators and learners alike. As e-learning continues to evolve, future research directions are poised to address the challenges and harness the opportunities presented by emerging technologies. The integration of AI and e-learning is anticipated to grow, providing personalized learning experiences and intelligent feedback, thereby enhancing the efficiency and effectiveness of online learning. Gamification and interactive learning experience are also expected to gain prominence. Approaches aim to revolutionize e-learning by making educational more personalized, interactive, and accessible. They aim to improve learning outcomes and engagement, suggesting a shift towards more learner-centered models. Adaptive technology is another area of focus with e-learning. Platforms likely to become responsive to individuals' learning needs. This includes adapting the difficult level of content, providing targeted recommendations based on real-time data analysis. Mobile learning is set to expand also, with an increasing number of learners accessing educational content on the go. This trend underscores the need for e-learning content to be optimized for mobile devices, ensuring accessibility and convenience. Finally, VR and AR are expected to transform the educational industry by making learning more immersive and experimental. These technologies offer new ways for learners to interact with content, potentially leading to deeper understanding and retention of information. Future research will likely explore the educational techniques that best leverage these technologies and the ethical considerations and best practices for their implementation. The goal will be to create e-learning environments that are both technologically advanced and educationally effective and inclusive. The exploration of cognitive theory and e-learning, particularly with the integration of emerging technologies, has provided valuable insights into the future of education. The evidence gathered from 2019 to 2024 underscores the potential of AI, VR, and AR technologies to enhance the learning experience by offering personalized, immersive, and interactive educational opportunities. However, the research also highlights significant challenges, including the digital divide and the readiness of institutions to adopt and support supportive learning. As we move forward, future research must continue to address these challenges while exploring the educational techniques that best leverage emerging technology. The goal is to create inclusive, effective, and engaging e-learning environments that cater to the diverse needs of learners worldwide. The continued evolution of e-learning will likely see a greater emphasis on mobile learning, adaptive technology, and gamification, all of which promise to make education more accessible and engaging for all. This body of research from 2019 to 2024 provides a foundation for educators, instructional designers, and policymakers to build to advance the e-learning field by embracing the opportunities presented today by emerging technologies and addressing the associated challenges. The future of e-learning can be boundless as the technologies themselves. The next couple of slides are the references that we discussed today in the articles. and the research I used in my paper and during this presentation. These are the YouTube links that you can copy paste. Go check those out. Again, thank you so much for joining my presentation today, and you have a blessed day.